Have you ever looked up at the night sky and just wondered, where else could humanity actually survive out there? Because let's be real, our solar system is incredibly hostile. Welcome to this explainer, where we're going to embark on the absolute ultimate cosmic stress test. We all know Earth is our perfect, comfortable little bubble, but what if we literally had to leave? Today, we are putting every other planet to the test.
So think of this as the ultimate Goldilocks survival tour. But we aren't just looking for, frozen water or tiny microbes. We are looking at instant death scenarios. We're going to hop from world to world, eliminating planets based on how quickly their environments would destroy us, until only one viable candidate remains standing. It's going to be a wild journey of extreme heat, crushing pressure, and supersonic winds.
Here is our flight itinerary for today. We'll start with the survival test, move into the heat of the inner planets, dive through the chaos of the gas giants, check out the freezing ice giants, and finally land on the Mars solution. All right, Section 1, the survival test. We're eliminating the impossible right off the bat.
Moving to Section 2, the inner planets' heat, specifically Mercury and Venus. You might think being closest to the sun just means, a really intense sunburn, but the reality is a nightmare mix of wild temperatures and entirely toxic atmospheres. The sheer scale of the temperature swings on Mercury is just insane. Because it completely lacks a proper atmosphere to regulate heat, the daytime temperature skyrockets to a flesh-melting 430 degrees Celsius, and because a day there lasts about half an Earth year, you can't exactly just wait it out in the shade. Nighttime isn't any better, plummeting down to a completely icy minus 180 degrees. To put that into perspective, the absolute latest, state-of-the-art NASA spacesuits can only handle limits between 121 and minus 157 degrees Celsius. So Mercury's environment completely shatters the capabilities of our most advanced technology.
Okay, so Mercury is definitely out. What about Venus, our closest planetary neighbor? Well, before you even reach the surface, you run into this number, 92. Venus has an atmospheric pressure of 92 bars. That is literally 92 times Earth's pressure at sea level. Just trying to move your arms and legs would feel like you're wading through deep, heavy liquid, and within seconds, this immense pressure would instantly crush even the most highly pressurized spacesuit.
And hey, if the pressure doesn't get you, the real estate on Venus is truly terrible. The temperature sits at an unbearable 450 degrees Celsius. Oh, and you know those beautiful yellow clouds you see in pictures from space? Yeah, they're made of highly corrosive sulfuric acid that would destroy your lungs in seconds if your suit happened to break. Plus, those thick carbon dioxide clouds block all but 10% of the sunlight, leaving you in a dark, incredibly dense, scorching hellscape. So, the takeaway here? The inner planets are an absolute no-go. Which brings us to Section 3, Gas Giants Chaos, Jupiter and Saturn. We're officially leaving rocky surfaces behind and falling into terrifying environments where there is quite literally no solid ground to land on.
If you tried to descend into these giants, you'd face absolute, utter chaos. On Jupiter, before you even get close, extreme radiation would penetrate your suit from 300,000 kilometers away. If you somehow survived that, you'd be pulled down by gravity 2.4 times stronger than Earth's, swimming through metallic hydrogen. Over on Saturn, assuming you dodge the ice pellets and asteroids whizzing around in its iconic rings, you are hit with hurricane-force winds blasting it up to 1,800 kilometers per hour. Just standing steady, let alone building a habitat, is entirely impossible.
And just to really highlight the absurd, terrifying scale of Jupiter, its core is estimated to be roughly 24,000 degrees Celsius. That is literally 4.5 times hotter than the surface of our own sun. Add in pressure that is 100 million times Earth's atmospheric pressure near its center, and yeah, it's safe to say the gas giants are entirely uninhabitable. All right, Section 4, the freezing ice giants, Uranus and Neptune. And by the way, ice giant doesn't mean a solid ball of ice you could just go ice skating on. It just means they're composed of heavier elements than hydrogen and helium. The environments here are staggeringly hostile. Uranus is actually the coldest planet in our solar system, with temperatures dropping below minus 200 degrees Celsius. But both Uranus and its twin, Neptune, feature incredibly dark, dense outer layers of toxic gas. As you fall through them, the pressure spikes to 100 times that of Earth's, which, again, is enough to eventually crush you. While Neptune hides an intensely hot 7,000-degree core right beneath that freezing exterior.
And all of this pressure builds into one of the most spectacular yet totally deadly weather phenomena in the universe, diamond rain. The immense pressure deep within these planets breaks down methane into solid diamonds. But trust me, you wouldn't want to be there to try and catch them. On Uranus, this diamond rain is driven by 900 km/h winds, and on Neptune, those winds actually reach supersonic speeds. Between the toxic atmosphere, the crushing pressure, and literally supersonic diamond shrapnel, survival is completely out of the question.
So if the inner planets melt us and the outer planets crush us, where does that leave us? Section 5. The Mars Solution, the most habitable option. We've eliminated the scorching heat, the crushing depths, the extreme radiation, and the supersonic diamond storms. We are now pivoting to the ultimate survivor of our solar system test.
It turns out, Mars is the second closest planet to Earth, and genuinely the most habitable of all 8 planets. It earns this massive distinction for a very specific reason. Its baseline conditions are the least instantly hostile of any non-Earth planet in our entire neighborhood. It actually has a rocky surface we can land on, and a gravity profile we can work with.
To truly appreciate why Mars is the winner, we just have to contrast it with the rest of the solar system. Remember Venus's hellscape peaking at 450 degrees Celsius? While Mars, on the other hand, can reach a peak daytime temperature of a relatively comfortable 20 degrees Celsius. Let that sink in. Compared to the 430 degrees of Mercury or the deep freeze of Uranus, 20 degrees Celsius sounds like an absolute vacation. It's a level of temperature stability that is uniquely manageable for human technology.
Now, obviously, that doesn't mean Mars is a complete walk in the park. It still presents serious survival challenges. Once the sun sets, those lethally cold nights drop to a freezing -153 degrees Celsius. The atmosphere is incredibly thin and mostly carbon dioxide, meaning there is zero breathable oxygen. You also have to deal with violent dust storms whipping up to 100 kilometers per hour. But here's the crucial takeaway. Unlike the 92 bars of instant crushing pressure on Venus or the 1,800 km/h winds on Saturn, the hazards on Mars are actually solvable engineering challenges. Though I will say, the biggest unseen hurdle is definitely the radiation. Because of that incredibly thin atmosphere and a lack of a strong magnetic field, radiation levels on Mars sit between 24 and 30 rads. That is up to 50 times the average natural radiation we experience right here on Earth. This means any attempt at actually living on the red planet requires serious, dedicated, full-time protection from those cosmic rays.
Overcoming these hurdles requires a highly specific technological approach. Surviving Mars means relying entirely on sustainable, absolutely airtight habitats. Because the atmosphere is so thin and lacks oxygen, every single structure has to be perfectly sealed. And to survive those -153-degree nights, well-insulated life support systems are completely mandatory. We basically have to bring our own mini-Earth environments with us, fully shielding ourselves from the high radiation and the extreme cold. We've seen exactly how quickly the rest of the solar system would wipe us out, so I'm going to leave you with this final thought to ponder. When you look at the massive engineering mountains we'd have to climb to build those airtight, well-insulated bases, is braving Mars's freezing nights in high radiation a fair trade-off for escaping the instant death scenarios of crushing diamond rain and sulfuric acid? What will it truly take for humanity to step up and conquer the red planet?